Hello, everybody. Welcome to our webinar, Ditch the Pitch, presenting which solutions we might think there are out in refractories producing without the use of coal tar pitch. I'm Peter Simons. I'm your host today, and presenting will be my colleague Tinus Bezuidenhout, live from Cape Town, South Africa. Tinus, how long are you in the industry already?
20 years, Peter, in this industry itself.
Good. Looking very much forward to hear what you can share with us. Please go ahead. I will turn my camera off, but I will still be there to change the slides for you.
Thank you, Peter. And of course, welcome to all the participants. This afternoon, we'll take a deeper dive and a look into this subject of replacing coal tar pitch in certain refractory articles, and more specifically, the viability of using phenolic resin for that purpose. In today's agenda, we'll discuss a few topics around these refractory articles. Then we'll move through shaped refractories and unshaped refractories, and then finally draw some conclusions. Thank you, Peter. Next slide. Right, under refractory articles, Peter, next slide, please. Right, some challenges that formulators and refractory companies are faced with these days. Everybody will know very well the tightening regulations under ECHA or REACH, if you prefer to call it. Specifically in terms of coal tar pitch having been placed on the list of substances of very high concern, which means it is now under review, and eventually a sunset date will be determined. The largest concern, of course, with coal tar pitch being the toxic substances in the emissions. We'll talk a little bit more about that later. And these carcinogenic substances in pitch, more specifically polycyclic aromatic hydrocarbons and benzoalpha pyrenes, of most concern. On the right-hand side, for you as the formulator and producer of these articles, it is fair to say that you at the same time need to consider properties and processing parameters such as cold crushing strength or compression strength, carbon yield, again, which fits into compression strength, and processing parameters such as flowability of a mix, extrudability of a mix, drillability of final products, and so on. Next slide, please, Peter. Something that we need to consider right up front, people often ask, how do you look at the cost comparison? And my advice here would be to always look at it holistically, to have a complete picture. If you compare the costs of coal tar pitch to phenolic resins, it is not a simple comparison, one-to-one comparison of raw material costs. You need to look at the total cost of ownership as it pertains to air emission licenses, annual applications for the use of CTP, in other words, all the permitting processes. Consider also your EHS equipment that you currently use and pay for, which people are wearing when in the workplace. Also extraction equipment or extraction ducting that you have to install for these emissions. Also consider other factors such as energy during storage of coal tar pitch to keep it in a molten state. Also, when it comes to health monitoring, think of biological monitoring and the frequency thereof. So there are many hidden costs that make up the total cost of ownership that you need to consider. Next slide, please. So we'll start now on the the subject directly of shaped refractories. Next slide, please. And everybody will, of course, recognize these articles, normally articles such as bricks, refractory bricks, crucibles, slide gates, flow control tubes, nozzles or submerged entry nozzles, tundish blocks, and lastly also ladle shrouds. Next slide, please. The type of attributes when considering to use a phenolic resin in the place of coal tar pitch. Typical attributes brought to the table by phenolic resins could be factors such as moldability, carbon yield. In some cases, like liquid resins, even a reactive solvent can be present. And in our case, we focus heavily on water contents because that relates directly to rejects, such as caused by cracking and lamination. And we also focus heavily on free monomer contents or residual monomer contents. The acronym there, ULF, ultra low free formaldehyde. And of course, we prefer to be below the declarable GHS levels of 0.1%. Another typical attribute could be something like melt viscosity or softening point in the case of solid phenolic resins. The, the typical advantages that phenolic resins bring is that it has been proven as a viable alternative in the place of coal tar pitch. It does not contain any of the polycyclic aromatic hydrocarbons or benzoalpha pyrenes that pitch contains. In other words, the toxicity profile of a phenolic resin is significantly lower than pitch. And then lastly, if you think of emissions from coal tar pitch compared to phenolic, uh, significantly lower emissions or toxic emissions from a phenolic resin, which is specifically important if you think of factories or production sites that are in close proximity to suburban areas. Next slide, please, Peter. We'll first look at a case study that we had recently where we replaced coal tar pitch as a binder in crucibles. And in this case, crucibles made by the process of casting followed by isostatic pressing, or as some people may say, continuous casting and then isostatic pressing. In our case, we used a direct replacement of the pitch by a resol, a phenolic liquid resol, dissolved in furfural alcohol as a reactive solvent. Of course, being a resol, it is heat reactive by nature, and being heat reactive, we are able to eliminate the use of any hexamine. If you think carefully, in the cases where you might use a Novolac phenolic resin, you would still require the addition of hexamine as a hardener or catalyst. In this case, in our case, we chose a resol, a heat reactive resol, eliminate the use of hexamine, and through the elimination of hexamine, you also completely avoid the evolution of ammonia gas during the coking process. So another component eliminated. We mentioned the reactive solvent being furfural alcohol, which may further contribute to carbon yield. And then lastly, the fact that we target very low water contents below 1% in our binder further lends itself to positive results in terms of quality in preventing cracking during the coking process. So here we have a very attractive, good example that works in practice. Next slide, please. I'll run through a few typical examples of the types of phenolic resins that you can consider using for the different types of shaped refractories or the different processes. In the case of the general types of bricks, we of course we referring to magnesite or mag carbon, chrome mag, aluminum carbon, and other types. The typical type of phenolic resin used would be a Novolac solution. And when we say solution, these could be in solvents, typically of high boiling point, but also sometimes used liquid resol water based. Because what you're typically looking for in these cases would simply be green strength and a certain carbon yield at the end. Or let's refer rather even to a cold crushing strength or compression strength that you're looking for in the end. In the case of dolomite bricks, where you cannot tolerate the presence of any water, we would rather prefer to use a resol in furfural alcohol. Of course, not even considering a water-based resol, but in this case, a resol in furfural alcohol with moisture content levels less than 1%. In the next item, we consider crucibles, specifically those that are produced by the processes of rib forming and roller forming, where you specifically look for a certain plasticity or moldability of the mix. And in this case, we would suggest the use of Novolac solutions in furfural alcohol as a reactive solvent. Of course, the Novolac providing the plasticity. In the next line item, we also consider crucibles and other items made by isostatic pressing, as well as all the other items made by compression molding, where you simply require a free-flowing mix, and you would consider phenolic resins such as resols in furfural alcohol or Novolac solution in furfural alcohol. And lastly, last item, in the case of the impregnation process, for the purpose of reduction of porosity in shaped refractories, whether you use the cold process or the warm process. In the case of cold process, you would consider resols or Novolacs in furfural alcohol. In other words, liquid material at ambient temperature. Or in the case of warm process, your consideration would be a solid Novolac with the prerequisite of having the lowest or a low softening point, a low melt point, for the sake of easy melting and having a low melt viscosity. Next slide, please. We'll jump straight across to unshaped refractories, where similarly to shaped refractories, we look at a few attributes that phenolic resins can provide. In the case of substituting coal tar pitch, and here we would look at plasticization or flow, which can bring flowability to something like a tap-hole clay. I've mentioned before that we always consider low water contents in all these applications, which is what we specifically focus on. You can tailor make your reactivities by choosing a reactive resol of a certain reactivity. And in our case, we often find that medium reactivity resols lend itself very nicely to this application of Tapple clays. Of course, carbon yield is always important. Um, for example, also in ramming masses, we consider reactive solvents again. And as mentioned before, the lowest possible free monomers in terms of free formaldehyde as well as free phenol. As I've mentioned before, plasticity and flowability of Tapple clays are also considered. On the right-hand side, it mentions exactly the same advantages that it brings, which I've mentioned in the previous cases of shaped refractories. Next slide, please. Again, we first look at a case study. In this case, we chose a Tapple clay of 1,2 meter length, replacing the coal tar pitch directly in a 1-to-1 ratio in terms of solids content by calculation. And the solution we provided in this case was to use a blend of liquid resols and liquid novalax in glycols. Now, what I would suggest here and or recommend is that if you are a formulator of Tapple clays, consider to use these components separately to give yourself the ability to manipulate the reactivity of the final Tapple clay. The very next point talks about that by changing the ratio of the resol to Novalac, you can manipulate the reactivity according to either to the length of the Tapple clay, or if you wish to manipulate the reactivity for the sake of shelf life. Think specifically about companies who export in containers at a certain temperature profile where you need a certain stability or shelf life of the Tapple. And the third point there, um, it's important to note that you can also manipulate the reactivity of the Tapple as well as the plasticity of the Tapple by the amount and type of glycol that you use. Now, everybody will know these glycols can vary from ethylene glycol, diethylene glycol, propylene glycols, and even polymeric glycols, um, like polyethylene glycol. Um, and depending on what you choose, which type you choose, and the size of the molecule, you can slow down the reactivity of the Tapple. But also take note, like we said before, also by playing with the ratio of the two components of Resol and Novalac, you can manipulate the reactivity very nicely. So again, not only for shelf life, but specifically the reactivity of the Tapple as it relates to in the mud gun, so that you do not get premature curing in the Tapple. Next slide, please. Again, we consider a few recommended types of phenolics for each application. In Tapple clays, where your process would be high shear mixing followed by extrusion through an extruder, you specifically require properties such as flowability for the extrusion. And in these cases, one would normally consider Novalax and Resols in whichever type of glycol that is chosen. In the case of ramming mixes or ramming masses, which is done by dry blending, consider always the water content in this mix for the sake of the final quality and to ensure that you do not get cracking in the lining, the furnace lining. Here you would consider phenolic resins of the types Resols or Novalax in fifral alcohol as a reactive solvent. Next slide, please. Very quickly, we'll draw some conclusions on this very short and quick presentation. I want to draw your attention to the right-hand side, and I've mentioned this a few times now. Differentiators that we as ASK Chemicals focus on is these properties that will bring the a, a marked decrease in reject rates. In other words, the best possible quality in use. And therefore, we as ASK Chemicals focus on factors such as water content in our binders and free monomers for the sake of the lowest possible toxicity profile. On the left-hand side, we then say that both in the case of shaped refractories and unshaped refractories, certainly phenolic resins lend themselves as a suitable replacement or alternative to coal tar pitch, where product attributes such as moldability, carbon yield, and flowability can be matched by the formulator through a certain exercise of formulation. And product performances, in the case of shape refractories, again can be achieved such as cold crushing strength or compression strength, crack resistance or lamination resistance, as well as spalling resistance in terms of dimensional stability. In the case of unshaped refractories, attributes of workability index, extrudability, and drillability can again be matched and achieved through the careful choice of raw materials, again, such as glycols, and finally leading to product performances in the case of tappel clays, such as rupture strength and compression strength, or in the case of ramming mixes or ramming masses, such as spalling resistance and heat shock resistance. Next slide, please. At this point, I will yield back to Dr. Peter Simons for any further questions.
Thank you, Tinus, for your presentation. Switch my camera back off. Thank you for this presentation. You're more than welcome to type any questions you might have either in the chat function, and I will forward them that everybody can see them, or reach out to us directly after this webinar. While you might be thinking of some of the questions, let me just give you a hint what you can expect on our website as well. We have product finders there, more white papers, technical papers. You can ask direct questions to our experts and can sign up for our newsletter. There are some questions received already. And the first series of questions is about the regulatory status of coal tar pitch. There's one question and one comment. So the question is what the regulatory status of coal tar pitch, and yeah, you basically can call it already an answer to this. Coal tar pitch is a substance of high rare concern. Annex 14 of the REACH regulations for the use is an authorization mandatory. The other types of pitch are not substances of very high concern. Anything you want to add on this? Yes.
Nothing further than what you've said now. Everybody always to be aware that it is under review and eventually a sunset date will be set.
Thank you. One specific question on our portfolio. Hydrogens, thank you for the presentation. Could you supply resins with different viscosities?
Of course, when you think of liquid resols, whether they are in furfural alcohol or water-based or glycol-based, of course, various different viscosities are possible. Um, in the case of resols, so much easier to control the viscosity, uh, depending on the base resol itself and the molecular weight thereof. And then, of course, further adaptations in viscosities depending on solvent content.
Thank you. We continue to talk about EHS. That seems to be the main topic of most of our attendees. Is there any EHS issue regarding furfural alcohol use?
Yes, when you consider using materials containing furfural alcohol, uh, be aware of the toxicity profile of um, furfural alcohol. It has a certain toxicity, uh, although not as severe as coal tar pitch. But be aware there is a certain toxicity linked to furfural alcohol. Study the STS, safety data sheets, carefully and make yourself aware of the precautions. Peter?
Thank you. We got another question on EHS related topics. We got information that benzene is emitted during the heating of phenolic resins. The amount could be relevant for health and safety at work in the steel plant. Do you have any information or research on this emission of benzene from phenolic resins during heating?
Specific levels of benzene throughout a coking process or baking process, if that is what is referred
Yeah.
to. Specific levels and studies thereof, no, we do not have that in hand um, in our case anyway. I hope that answers your question.
Fair comment at least. Let me switch then to some of the more technical questions we received. One is, can you please elaborate on why this will improve flowability of mix?
I think it sounds like what is referred to here is flowability of a tapple clay. And my comment there was you can quite easily match the flowability of a tapple clay mix uh, as it pertains to extrusion process. And what we mean by that is through the use of glycols as plasticizers itself, you can mimic the plasticity. Also, with the presence of the Novolac component itself contributes to the flowability or plasticity, right? So those two components, the glycols plus the presence of Novolac, mimics and give a very good um, copy or equivalency in flowability.
Thank you, Tinus. Another related question, what is the effect on hot modulus of rupture?
The effect of this kind of replacement on the hot modulus of rupture.
Mhm.
Let me put it this way. So there are so many different articles that you can consider here. Okay, let's answer take something else into consideration because this question is quite wide. If you directly replace coal tar pitch with phenolic resin, in the case of a Novolac, you will probably do it 1-to-1, right? And in the case of a Resol, you will probably calculate it on solids content so that you have equivalent binder content. One thing to remember is that a phenolic resin or phenolic novolac also normally give in a direct one-to-one replacement of coal tar pitch normally shows a higher compression strength than the coal tar pitch case. So that is part of the answer. So if you replace one to one on solids content, you may see higher compression strength. So and you can draw your own conclusions that would relate to modulus of rupture, of course. The other point to consider here for the formulator is be careful not to only focus on carbon yield. Because of this factor of a novolac, for example, a phenolic resin, giving a higher compression strength than coal tar pitch, you do not need to focus solely on carbon yield or to match the carbon yield, the carbon content, because of this strength difference. So my advice would always be don't formulate on carbon yield or carbon content, rather fine tune and formulate firstly on solids content and after that fine tune on strength, because that's the important factor finally in the final article, right?
Mhm.
So like I said, don't be too scientific when it comes to the replacement and focus on specific factors such as carbon yield. Rather go for the one-to-one solids replacement, achieve a certain strength, and then you can cut back and fine tune on that strength factor. Okay, hope that answers the question more broadly.
At least it provides a nice bridge to the next set of questions, because the next one is indeed, how does the yield value change? So we talked already about carbon yield, but this was specific also here. How does it change? I guess from coal tar pitch to a phenolic resin.
Okay, so always keep in mind where your coal tar pitch may give carbon yields, which can be anything from 50% to 58%, for example, and a phenolic resin, in the case of a novolac, may yield something like 44%. And you can, so in your, and similarly, in the case of a liquid novolac, you will have to compensate for solids content, right? So let's take this typical example of a 20% less carbon yield in a phenolic resin compared to a coal tar pitch. And this is exactly why I said do not blindly stare at this factor alone. This property alone is not the final answer. Always first look at the fact that a phenolic will give you the higher strength and then fine tune on this attribute. Okay. So again, please don't only consider carbon yield. The 20% less carbon yield in many cases already provide a higher compression strength. And that is the answer to the final solution.
Thank you, Tinis. We continue to receive questions, so I hope you don't mind if we just continue for another 4 or 5 minutes trying to answer all of those. The next one is, what is the maximum carbon yield when we use it in shape refractories, and what would be the recommended viscosity level?
I'm trying to make sure I understand this question correctly. You said, what is the maximum carbon yield? I think we've just discussed carbon yields of typical novolacs around the 44%, right? But then the rest of the question, Peter, just confirm again the question around viscosity.
What would be a recommended viscosity level?
Oh, across the various applications, and now it depends on application, on the article, not only on the article but also the process that you follow, and it's across a broad spectrum. I mean, you can imagine from the field of bricks, where people vary between 10 poise and over 100 poise. Then in the area of crucibles, you may be typically, for isostatic pressing, vary between 10 and 20 poise. In the area of Tappel clays, you may vary easily between 30 poise and 100 poise. So it really depends on what article and what process you are using, um, before you before you choose the viscosity of a phenolic resin.
Mhm.
Peter?
Thank you. Next question, what is the advantage of furfural alcohol in comparison with a glycol?
Okay, so when we talked about glycols, we were referring specifically to Tappel clay mixes, and it applies to that application. But when you talk about furfural alcohol as a reactive solvent, um, we we use those types in ramming masses, um, isostatic pressing. Um, you would have remembered on the shaped refractory slide. So various applications in shaped refractories using furfural alcohol as a reactive solvent, but not to confuse it with glycol, glycol being very specifically related to Tappel clays.
Thank you, Tinis. Then let's continue to talk a little bit more about tap hole clays. What resin? Oh, sorry, I switched already to the next one where resin application is better. Tar impregnation, how?
You'll have to please repeat the question, Peter.
Whether resin impregnation is better than tar impregnation, and if yes, how?
Okay, so in fact, very similar. This, depending on the chosen melt or softening point, relating directly to the melt viscosity. So you would know in the case of cold hard pitches, you have a certain melt viscosity at a certain temperature, and the idea when replacing with phenolic resin would be to mimic that as closely as you can. For example, for impregnation, if you are used to using cold hard pitches with a softening point anything between 90 and 95, 90 to 98 degrees Celsius even, you would choose a phenolic resin of equivalent softening point. Peter?
Thank you. What is the effect on drilling properties of tap hole clay using tar or resin?
The effect on drilling properties in Tappel clays. Right. So when you're trying to copy or match the drillability of the Tappel clay, take care with your content and the ratio. What I mean by that is the amount of glycols present, which is what will give you the plasticity and drillability, but secondly, balanced with the amount of binder, in other words, how much Novolac and Resol you have incorporated. So, in your formulatory exercise, you would typically um, formulate with a certain ratio and settle on a certain ratio of Novolac to Resol, which might be something like 40-60 or 50-50. And inherently, these two components would have a certain glycol content. And let's assume that can vary anything between 20 to 35% contents of glycols. So in the case where you are trying to match the drillability, you would it is a little bit of an exercise to go through the empirical exercise of finding your and fine tuning the correct drillability based on how much binder you have incorporated, Novolac and Resol, into a certain ratio, keeping in mind that it contains a certain amount of glycol. So again, it is an empirical approach. You will have to, let's call it, play around. You will have to empirically find the balance between the amount of binder and the drillability because of the presence of a certain amount of glycol. Peter?
Thank you, Tinus. The next question goes also on the relationship mixture between Resol and Novolax and glycol addition, but it's asking about the effect it has on the shelf life.
Right. Okay. Again, shelf life of Tapol clays. Right. So when you are formulating um, the, the the shelf life being closely related to the reactivity, um, the way or the suggestion there is, of course, the longer shelf life you require or lower reactivity, in other words, you would increase your Novolac component, decrease the Resol component, and you may very well find that you are moving in the area of 60% Resol to 40% Novolac, and then fine tune it up from there, 65, 35, and so on. In the most extreme cases, 70, 30, to find that reactivity that you desire. Now, in the fine tune of this reactivity, pay close attention to the effect it then has on drillability, for example. But essentially, it is by playing with this ratio, you will be able to fine tune your reactivity and therefore shelf life. But the other thing to always consider, like I said before, consider what kind of glycols you have incorporated in those components. Um, for example, if you have chosen a Novolac component, typically in ethylene glycol, consider what type of glycol you may choose in the Resol component. In most cases, in general cases, it might be ethylene glycol. But if you really want to lower or slow down that reactivity of the Resol component, choose a higher glycol. For example, diethylene glycol or propylene glycol. And that can really slow down the reactivity significantly. Peter?
Thank you, Tinus. I must admit, I feel a bit overwhelmed by all the good questions we are receiving, and we don't seem to stop receiving questions. For the sake of time, originally we planned for this to be 30 minutes. Now we are already at 45 minutes. So I would propose right now to call it off. You see here our email addresses, so please feel free to reach out to us directly if you want to continue this dialogue on a different scheme. Thanks again to everybody who joined us today. We had a nice list of attendees. I hope it was interesting for you. By the quality and the amount of questions, at least I think there was quite some interest from your end. Thanks again, and hopefully talk soon. Bye bye.